The purpose of today's lesson is to explain the basic operation and components of an artificially intelligent system and how it uses those components to simulate intelligent behavior. We're going to focus ourselves into two domains only: expert systems and machine learning. You already know a bit about machine learning, so there's not a lot to do there. So we're going to start by looking at expert systems, what they are and how they work. An expert system is a form of AI developed to mimic human knowledge and experience. These use knowledge and inference, which is reasoning, to solve problems by analyzing responses to a series of questions, thus mimicking a human expert. For example, you could have a doctor, and the doctor will ask you a series of questions, take a few measurements, and based on that, will work out what illness you have and what possible course of treatment that you should take. Now, these systems normally involve a human expert who knows what they're talking about. Maybe you look at books and so forth, and a knowledge expert, who's the designer, will curate that knowledge in a database called a knowledge base. An inference engine is used to query that knowledge base, and a user interface is provided so the end user can interact with this expert system. We're going to look at that in a bit more detail in a moment. But first, we're going to look at the uses of expert systems, where they're used at the moment. Expert systems are generally used in industries such as oil and mineral prospecting, diagnosis of patients' illnesses, so in the medicine sector, fault diagnostics in mechanical and electrical equipment, tax and financial calculations, logistics, for example, what's the most efficient parcel delivery mechanisms, which route to take, and so forth, identification of plants, animals, and chemical compounds, strategy games, for example, chess or Go, and even expert systems have been used in shows like Jeopardy to beat humans. Expert systems involve automation of knowledge, so you don't actually really need a real person there to query most of the knowledge. And in a way, when you're searching on Google or using ChatGPT, you're kind of using an expert system which has access to a huge amount of human knowledge. So how does this expert system actually work? We can look at it through two different directions. One's from the user side, the other is from the expert side. So let's start by looking at what happens from the expert side, which is the right hand side on this particular diagram. So first we collect a repository of facts. It stores all the knowledge about a given subject. It is a collection of objects and attributes. Now these are the technical definitions for the knowledge base, so you need to make sure you jot them down somewhere. Each one of these is a point in the exam. So a repository of facts stores knowledge about a given subject. It's a collection of objects and attributes. We then create something called a rules base, which is a set of inference rules, and these are used to draw conclusions using logical thinking. So these rules are again created by the programmer or the expert, the knowledge expert, not the actual human expert, but the knowledge expert, how knowledge could be queried. The inference engine is the main processing element of the expert system. This is now in the middle part. It acts like a search engine examining the knowledge base for information that matches the queries. It gathers data by asking the user a series of questions and applying responses. The inference engine is the main problem-solving part of the expert system. It makes use of inference rules in the rule space, so it queries both of those databases. A parallel system called an explanation system is also in place because this informs the user how the expert system arrived at its conclusion. So the reasoning has to be explained as well, otherwise there's no trust. Both of these systems are utilized by the user interface, which is what the user or the end user uses to query the system. This is where the expert system interacts with the user. It uses dialog boxes and command prompts. So you're going to type a command in, maybe you're going to select a few responses from a dialog box, and those then go into the inference engine, which then uses the rules base and the knowledge base to come to a conclusion. And then the explanation system presents that back via the user interface to the end user. Now, each of these boxes that you see on screen is a vital component of an expert system, and you should know how each of these parts work and how they're related to each other. So do pause the video and take some time making notes and studying this particular part. Each section could be asked about in the exam, and normally this would be a mark or 2 marks or up to 6 marks for the entire thing. Now, expert systems, just like everything else, have certain advantages and disadvantages. You need to be aware of a few of them. What are the benefits of expert systems? Expert systems allow you to access a high level of expertise and are often very accurate. All the knowledge for one particular human can often get lost if the human dies or is not available. So having that available in an expert system allows future generations or even a huge number of people around the world to benefit from it. They give consistent results. They can store vast amounts of information. People can be trained to use these systems even if they're not experts in particular fields. So having access to the knowledge of globally expert doctors can be utilized by other doctors who might be new to the profession and still be able to benefit from their experience. They can make traceable logical solutions. They can have multiple areas of expertise, not just one. They often give you very fast response times, unbiased reporting. They give the probability of the solution or the suggestion being correct rather than absolute certainty, which often humans fall into a trap with. For example, when we think that our solution, our response is accurate and we come up with a huge amount of certainty, whereas the system might say, well, it's only 50% certain or 75% certain, and then the end user can make their decision. Of course, there's a huge amount of disadvantages as well. Users need training to operate them correctly. They need to be set up, and maintenance is costly and time consuming. You need to collect the data, you need to create the databases, you have to maintain it. All of that costs money. They tend to give a very cold response that may not be appropriate in certain circumstances. Like a doctor would look at the patient and perhaps bring that human element into play. A system will just give the answer straight away. They're only as good as the information entered into the knowledge base. So garbage in, garbage out. So you've got to make sure that the knowledge is vetted and it is accurate. Users sometimes make the dangerous assumption that expert systems are infallible. This happens all the time. Most students, for example, will look at ChatGPT and assume everything that ChatGPT gives you is accurate, and that's really not true, and that's been proven not to be true. So you really need to query your sources and check things out. But often people believe a system is much more accurate than a human. So try to remember a few advantages and disadvantages of expert systems. So summarizing the process of setting up an expert system, make sure you remember these steps. Each step would be worth a points in the exam for a 6 marker. Information needs to be gathered from human experts or sources such as textbooks, research papers, or the internet maybe. A knowledge base is created first and gathered information is stored in it. This is normally done by a knowledge expert. A rules base is created, and this is made up of a series of inference rules. So the inference engine can draw conclusions. This is the reasoning part. The inference engine needs to be first set up. It is a complex system since it's the main processing element making reasoned conclusions from data in the knowledge base. So those rules have to be really logical, and this is where most of the work is done. The UI or the user interface needs to be developed to allow the user and expert system to communicate. Once this system is set up, it needs to be fully tested. This is done by running the system with known outcomes or labeled data so that results can be compared and any changes to the expert system made. If we input this set of data, we should be expecting this set of outputs, and then you keep testing it and testing it and testing it, and once it works perfectly, then it can be launched with the public. Okay, that's all there is to expert systems. We also need to know a bit about machine learning. Now, we looked at that in brief form in the last lesson, so we're just going to delve into it in a bit more depth. Machine learning programs can automatically adapt their own processes and or data. They use algorithms to analyze data and identify patterns or relationships. They can learn from data and improve performance over time. They can be both supervised or unsupervised. What does that mean? Well, supervised machine learning uses labeled data to train the system. Unsupervised machine learning uses unlabeled data to train itself. So it takes longer for an unlabeled machine learning system to train itself compared to a supervised machine learning system. A human is often involved in that particular stage. So generally, expert systems involve some kind of supervised machine learning. However, more and more systems are becoming unsupervised because they learn on their own and then make their own knowledge links, which can lead to new knowledge. So if you want to do things like predictions of climate change or detect new diseases, then we might use unsupervised machine learning and deep learning systems rather than a supervised learning system, which only relies on expert human knowledge that already exists. So it cannot develop new knowledge. So please make sure you know the definition for machine learning. The first 3 points are a mark each in the exam. You might also be asked about supervised and unsupervised learning, and they are pretty straightforward. So please do mention the use of labeled data and the use of unlabeled data. Okay, that's all for today. Hopefully you should be able to answer the following questions. You should be able to explain what is meant by an expert system. You should be able to describe how an expert system works. You should be able to list at least 3 uses of expert systems, and you should be able to describe how an expert system is set up. That's the big 6 marker. You should also be able to list 3 advantages and 3 disadvantages of expert systems. What is meant by machine learning? You should be able to explain what is meant by supervised systems and unsupervised systems, and also in a way be able to explain the difference between them. That's all for today's session. If you do have any questions as usual, please do post them in the comments. Otherwise, I'll see you in the next one.